Hi everyone. My name is Lurdakash Mamnani, and today we are here to present our topic speech to text. Today we live in a world where our spoken words are instantly converted or transformed into text with near perfect accuracy, helping people with hearing impairments or improving accessibility in technology and streamlining how we interact with our devices and many more stuff. And speech to text is is also known as automotive speech recognition. And the technology behind this transformation, it combines the power of acoustic modeling, language modeling, and signal processing to convert audio signals into readable and editable text. And over the years, as we can see, due to the vast improvement in technology, thanks to deep learning and neural networks, we were able to see rapid progress and evolving in the automotive speech recognition. And so, and most of the help we could say is given by natural language processing with the integration of the voice into it. So, moving on to the next slide, we can see that the speech to text converts spoken words into written text by processing audio input, which allows the machine to listen and respond, transforming how humans interact with devices or any other stuff we interact on a daily basis. And in NLP, particularly, we can see that the speech to text helps us build a more interactive environment and it allows us to naturally speak the commands rather than relying on typing typing the stuff, which consumes a lot of time. And it's an invaluable asset if we move on to the applications like virtual assistants, which every one of us use, like the Siri, Alexa, or any of the virtual assistants you use. And it also has a broader trend towards more natural human computer interactions rather than a very mild interaction with the computers and all. And as we move into the further slide to look for the definition, and we can say that speech to text technology helps the machine learning algorithm to interpret the human spoken language as text, which involves both identifying speech patterns and understanding language structures. So basically, speech to text works on capturing the audio signals first, and then the captured audio gets converted into digital form. And the converted audio is used by the machine learning models to analyze those patterns to extract the speech signals from the noise, then breaks it down and matches sounds to potential words, which we can see and as written text. And these speech to text systems are integrated into NLP workflows, which allows system to handle spoken commands or queries seamlessly. This integration enables applications like voice search and real-time transcriptions in messaging apps. Then moving on to the importance of speech to text in natural language processing. If we look around, we can see numerous applications of speech to text, and most of them is its accessibility to users with, who are disabled, such as those with limited mobility or visual impairments. And this technology helps them access using their voice, making digital content or tools more inclusive. And upon using speech to text, the efficiency of translating speech into text is almost spontaneous, which reduces the time required for data inputs. And particularly, it's useful in areas where typing might be slow, which consumes a lot of time. So it's time efficient, we could say that. And speech to text enhances the NLP models by providing additional data sources like audio inputs, which improve the model's understanding of language context and meaning, especially in complicated tasks like sentiment analysis or intended detections. And moving on to the key components of speech to text systems, we it's mainly divided into three: the audio processing, feature extraction, and decoding. So, audio processing is nothing but capturing the audio and processing the background noise or the unnecessary noise which we are having to enhance the clarity and standardizing the signal quality. And the techniques like noise reduction and signal amplification are applied here to improve the quality of the input during the analysis. And coming to the feature extraction, such as acoustic features like frequency, pitch, and tone, and are generally extracted in the feature extraction from feature extraction. These features help the model distinguish sounds that make up words and phrases. Mel frequency septal coefficients are common methods used in speech to text systems to represent sounds in a way that models can process. And when coming down to decoding, during this phase, the model matches the extracted features to possible phenomenons and words, and the language models further refine these predictions based on the context, making the system capable of predicting words even in challenging audio conditions. And now my friend Vamshi would be taking over from here.
Yeah, hi, myself Sayamshi. So let's discuss about acoustic modeling. So acoustic modeling maps audio features to linguistic units such as phonemes. Phonemes are the distinct units of sound in a language. Coming to the techniques are hidden Markov model and deep neural networks. So hidden Markov models traditionally used to model sequences of sound, and they are effective in representing the temporal dynamics of speech. So coming to the deep neural networks, modern systems often use deep neural networks due to their ability to capture complex patterns and perform well in noisy environments, so leading to more accurate mapping from sound to text. So the challenges faced are variations in accent, speech speed, background noise, and other factors can impact model accuracy. Each of these can create discrepancies that models need to adapt to, often requiring large datasets for effective training. And coming to the next slide, the language modeling. So the probability estimation. So language modeling estimate the likelihood of certain word sequences appear together based on training data, which helps improve recognition accuracy. For instance, New York is more likely to appear together than random word pairings. And coming to the grammar rules, basic rules of language such as subject-verb agreement, common syntax structures can be programmed into models, improving their ability to predict and structure sentences naturally. And the last one is continuous learning. So modern STT systems adapt over time, learning from user input to incorporate new vocabulary, slang, and evolving language patterns. This is often accomplished through techniques like transfer learning and fine-tuning of pre-existing models. And the next slide is about the pronunciation modeling. So in this one, the first one is a phoneme mapping. Links to word to the corresponding phonemes using phonetic dictionaries, allowing STT systems to handle diverse pronunciations. And the next one is a multilingual support. Advanced STT systems can recognize multiple languages and dialects, increasing accessibility worldwide. This requires extensive training across multiple languages. And coming to the accent adaptation, STT systems adjust to variations in accent to improve recognition. Accent adaptation can involve additional training data or specialized accent detection models to accommodate differences. And coming to the challenges in the next slide. So the challenges we faced are background noise, speaker variability, continuous speech, and context understanding. So coming to the background noise, the real world environments have variable or varying noise levels, which makes accurate speech recognition more challenging. And coming to the speaker variability, differences in tone, speed, and accent are completely two recognition models, requiring adaptation mechanisms. So continuous speech, in natural speech, words often blend together, like which is known as co-articulation, and segmentation becomes difficult. And models need to interpret intent beyond literal words, especially when content or implied meanings play a role, such as sarcasm or idioms, etc. So from now on, my friend Pranay will continue.
Hi there. Thank you, Vamshi. So, coming to the advancements in deep learning for the speech to text concept. So, in advancements, we have three features. They are recurrent neural networks, also called as RNNs, and transformer models, and the end-to-end models. Coming to the recurrent mode, coming to the RNNs. So, RNNs are a type of neural networks specifically designed for processing sequential data like audio signals or text. They maintain a memory of previous inputs, which allows them to capture temporal dependencies over time. Like how the RNNs work. In an RNN, each step in the sequence passes information to the next, creating a chain like structure. This hidden state acts as a memory, helping the network retain past information in sequences. And also, LSTM is also known as a long short term memory, and GRU, which is abbreviated as gated recurrent unit, are the advanced types of RNNs. Coming to the advantages of the RNNs, these captures temporal dependencies, like the RNNs handle sequences well, making them suitable for speech data, which is inherently sequential. And coming to the transformer models are a newer architecture that has revolutionized NLP, including speech to text. Unlike RNNs, transformers don't process sequences in order. Instead, they look at all parts of the sequence simultaneously. This parallel processing is made possible by the self attention mechanism. Coming to the advantages of the transformer models, they are the long range dependencies. Transformers can understand dependencies across long sentences or audio sequences more effectively than the RNNs. Coming to the end-to-end models, these are streamlined approach to the speech to text where the models directly maps audio inputs to the text outputs and featuring the extractions and decodings. In contrast, end-to-end models eliminate these steps, simplifying the pipeline. The advantages of the end-to-end models are they reduce the complexity of the traditional multi-stage STT systems, making them easier to train and deploy. They have the higher performance when compared to the two other models, and they also adapt more easily when compared to the other models. Now coming to the real world applications of the speech to text in NLP. Here we have three varieties, and in that healthcare, speech to text assists in documentation by allowing clinicians to dictate notes which are then transcribed, improving efficiency and patient record accuracy. Coming to the businesses, the use of the speech to text in the businesses is the real time transcription in virtual meetings, aids accessibility productivity, and can also serve as a record for future reference. In the car voice, in the automotive systems, we rely on speech to text to provide hands free control, enhancing safety and convenience for the drivers. Here, in the example, we have used the speechnotes.com website for transcribe, which illustrates a practical use case showing the transcription results. And this example demonstrates the ease of the speech to text transcription tools and provides a real world instance of the concepts discussed. So let me show you how we have used the speech to text in the real world. So this is the website, which is the speechnotes.com or dictate. So let me just dictate a sentence to that so that will give me the transcribed text. Speech to text technology works by picking up on these vibrations and translating them into a digital language, though an analog to digital converter. The analog to digital converter takes sounds from an audio file and then transcribes them. So you can see that from here I have done the speech to text technology, which then transcribed it into a text and given it to me. So now coming to the conclusion. So as in conclusion, speech to text technology has become essential in the natural language processing, transforming how we interact with the digital systems through natural voice driven communication. Advances in deep learning models like the RNNs, which we have discussed earlier, transformers, and also the end-to-end architectures have improved both accuracy and efficiency, making speech to text more accessible and adaptable across various applications. Despite ongoing challenges such as handling background noise and speaker variability, the future of speech to text holds immense potential for enhancing accessibility, productivity, and seamless human computer interactions. Thank you.